Okay, let me summarize. Let me summarize the 6 steps again. Step number 1, state the hypothesis. The null one. Yeah. This must be mu is equal to a value. And we had 3 kinds of the inequalities is or less. And again, it's not equal to, we need a p-value from the two-tailed later for the p-value, and greater than right, and the less than is left. Yeah, that is the place where we have to get the probability for the p-value. And the second one, we need the alpha. The name was the significance level. And step 3, we need the test statistic, which was a z-score. It's based on the mean difference. It's between the two means. The sample mean and the initial setting is a population mean. And now is always the sigma was assumed is to be known, right? So we got the z-score. Then we get the p-value. Yeah, it's again as from the place, the two-tailed, right tail, left tail. Yeah, we got the p-value. And simply just compare to the alpha, then make the decision and the conclusion. You know, the other way, the conclusion can be the interpretation. Yeah, it's the same thing. So we have 6 steps, right? Yeah. So good, right? Please remind the decision. And actually, we made the decision reject the null when if the p-value less than alpha, then we rejected the null hypothesis. The other way, what? If the p-value less than equal to or greater than, yeah, is a not to reject. So we had 2 statements, reject the null or not to reject the null. You know, I told you, you must not say accept, right? Yeah. You know, because we have only 2 decisions, is reject the null hypothesis or not to reject the null hypothesis. It is the same reason we have only 2 statements in the court. What is the 2 statements from the court? I judge guilty or not guilty. It's the same thing.
But not saying innocent, just saying not guilty.
Yes. Yes, it is. Right? Yeah. Because, okay, so now please come back to statistics. Very beginning, we assumed unknown population mean was the mu 0. Very beginning, we assumed. You know, we don't know. We didn't know how much is the population mean. So in step number 1, we assumed the unknown population mean was equal to mu 0. So because of that, we plug the value into the test statistic to get the z-score. How did you get the p-value? Absolutely from the z-score. From the left tail right tail, or even two tail. Then now we compare to the alpha to make the decision. So please go back. P-value, z-score. What is the decision for? We have to make the decision, we have to make the conclusion for the assumptions, for the null hypothesis. Actually the hypothesis test is actually, it is for the null statement. Yeah, why not? We have to make the conclusion. We have to make the conclusion for the null hypothesis. In the decision, we don't care. We don't care what was the claim, what was the alternative hypothesis when we made the decision, right? The decision is only for the null hypothesis. When we use the alternative hypothesis, when we got the p-value, less than left tail, greater than right tail, not equal to two tail, only in step 4, when we got the p-value, we needed alternative hypothesis. But the other steps, the others is based on the null hypothesis. So now, in the decision, step 5, we have to make the decision only for the null hypothesis. Does it make sense, right? Yeah. So please remember, we have only 2 decisions. Again, reject the null hypothesis or not reject the null hypothesis. Good, right? Does it make sense, right? Okay, last one. It's not the last one. Think about the alpha. What was the name of the alpha? Significance level. Think about the significance level. Actually, the significance level is another probability. I suggest to you is most of the time it is 1%, 5%, or 10% probabilities. Because of that, we compare the p-value, because the p-value was another probability, is compared to the alpha, a probability, 1%, 5%, 10%. Then please look at this. Why we reject the null hypothesis when the p-value is less than or equal to the alpha? If we want to understand why in that case we reject the null hypothesis, you have to know what is the p-value. The lecture notes is suggest us the definition of the p-value somewhere. Yes, here. Yep, it's trying to read the p-value. It is page number 4, at the bottom of the page number 4. Do you understand? Do you understand what is the p-value exactly? It is not easy for me. It is not easy to understand what is the p-value for me, right? So now, let me give you another definition. The simple definition. P-value is actually, it is a probability. Simply, the null statement is true. How do you think? One day, I insisted my height is 6 feet. Definitely, you have to state the alternative hypothesis. No, you are not. Less than 6 feet. Left tail. So, Yeah, is any alpha is up to 10%, and the test statistic and p-value. How do you think? What will be the decision? The conclusion, absolutely, the conclusion will be it's not true. Dr. is a liar, right? If you want to make the conclusion, if you want to interpret Dr. is a liar, then you have to reject the null hypothesis. Does it make sense? He liar. If you want to reject the null hypothesis, what does it mean? The p-value must be less than or equal to alpha. Any alpha, but the p-value must be smaller. Does it make sense, right? Yeah. What was the p-value? The null p-value is the chance, the probability. The null statement is true. P-value is the probability. The null statement is true. How much do you expect the p-value? The null statement is true. What does it mean? The null statement is true. Dr. is 6 feet. The chance will be impossible. Any alpha, you know, the smallest alpha is a common 1%. Absolutely impossible event less than 1%. See? So please understand what is the meaning of the p-value. Absolutely reject the null statement, and we made the conclusion, interpretation, he lied. It is not true. And now think about the alpha. At most 10%. At most 10%. Please think about the probability alpha. The significance level is up to 10%. I want to show you how much small enough the alpha 10%. Please look at the outside. It's many times I went to weather.com. Yeah, it's weather.com. Just a second. $10. Friday. Please look at the Friday. Yes, here, Friday. What is the chance of rain? 22%. Saturday, 24. Oh, Sunday, 32. Do you expect rain weekend? Come on, 30%, 20%. See? With the 20%, even 20%, you can trust it. Why? 20% is small enough, right? Okay, fine. But think about the alpha. It's only up to 10%. How? How we can trust it? We must reject the null hypothesis. Less than 5%? Oh no. No, impossible. We must reject the null hypothesis. See? So the other way I can tell you 10% is very strict. That means if we have a p-value 15%, if we have a p-value 20%, I can say the null statement is true 20%. It's 20% raining, even you don't trust it, right? But with a 20% p-value, unfortunately, we cannot reject the null hypothesis. But still, we don't trust it. But we set up the alpha is most of the time is 1%, 5%, 10%. Even the biggest one, 10%. If the p-value is less than 10, no, really, it is not. Less than 5%, less than 1%? No, never, ever. Right? So the reason why we have three kinds of the alphas, even 10% is small enough, because when we have a data from the lab, in chemistry, biology, or physics, when we collect the data from the lab, we have to apply it's more strict. In that case, it's 1%. Is there any other field? Is a social science? Is a criminal justice? Or and sometimes it's nursing. From the survey, there is more error. We can expect is more error. We have to be generous, right? But it's only up to 10%. And nobody set up 20% the significance level. It's only up to 10%. So it's a middle, yeah, it's most of the time, yeah, we set up is a 5%. But remember, 10% is a strict enough. It is very strict enough, right? So please think about your feeling of the chance of the rain. Yeah, 10% is very strict. Even the 10% is very small enough. So now I can interpret you why we need the 6 steps. Oh, the last one, conclusion. Just a second. The conclusion was from the decision, right? Why we have to make the same decision. And actually, the conclusion was from the decision. It's the same thing. Why do we need the conclusion? Why we have to interpret? So please look at the step 1, 2, 3, 4, 5. Actually, yeah, think about this example. When I show this example to my daughter, she is the high school. I have 2 daughters, the younger one in high school. Probably she could understand. Oh, Dad, yeah, I understand. What is the problem? But when I suggest to her, okay, then now step number 1, the null hypothesis is must be 275, and HA is the mu is less than 275. And can you see the alpha, the significance level was given 5%, and the test statistic is must be the z-score step 3, the x bar minus mu 0 over sigma over square root of n. Then the p-value will be this one from the z table. So we reject the null hypothesis. When I stop there, how do you think? My high school daughter. Oh my God, they couldn't understand anything. See, somebody said, why do you need a degree? Why you are here? Why do you need a degree? The bachelor degree? For the job. Yeah, one day I told you, right? It's for the job. Okay, good. So you finished, you completed the statistics, and finally you got the bachelor degree. It's a graduation, so you will have a good job. So your boss, so you have a job as a good company. So your boss is asked you this kind of example. It's a try. So one day you give a presentation in front of your boss. So you present is like this. Okay, so the problem. So you can state the null hypothesis and alternative hypothesis in this way in step number 1. And I set up is alpha is 5%. And now step 3, yeah, we have to get the test statistic. So we get the p-value from the z table, right? And the decision will be rejected. Period. Finish. What do you expect? That is the good answer from your boss, but you might be fired. Because nobody wants to get anything from statistics. I told you, everyone hates it. So probably the kind boss, this nice boss, asks you, so what? So what? So what? That will be the conclusion. Okay? So please look at the step number 1. The step number 1, 2, 3, 4, and 5 is very statistical steps. Mu, that is a notation in statistics. Alpha, that is another group letters in statistics. Z for the standard normal distribution, the test statistic in statistics. P-value, decision, everything in statistics. Everybody hates it, right? So please, you don't have to present. You don't have to present as any statistics parts. Just suggest to them, he lied. He lied. And also, additionally, you can add statistics. Statistically, we can prove he lied. And everybody trusts him, you know? And that is the good one. That is a good one for me, right? Everybody trusts me because I majored in statistics, even though I consist of 6 feet. Never mind. It is not true. Yeah? See? So that is the reason why, even though the step 6 and 5 is statistically is totally same, right? But we have to explain that, interpret what is the meaning of the decision, right? Yeah. So it's in English. Yeah, in English, it's not a statistical language. Yeah, we have to make the decision again in English. That will be the step 6, the conclusion. So please understand the 6 steps, and it's a step by step. And what is the meaning of the alpha, and what is the interpretation of the p-value, and why we have to make the decision reject the null hypothesis when the p-value is less than or equal to the alpha. And also, please understand why we have only 2 decisions: is reject the null hypothesis or not to reject the hypothesis, and why we have to repeat the 6 steps. I mean, the step 6, the conclusion. Yeah. So it is yes. It is the hypothesis test for, yep, please add unknown. Yeah, always I want to add unknown. Oh, when sigma is known. Yeah, always we assumed we knew the sigma, right? Yeah. So we name is on this one. It is a 1 mean z test because we use the z test statistic. So step number 1, step number 2, step number 3. Yeah, exactly same thing, right? And please don't look at this. Yeah, we got the p-value, right? So we got the p-value in step 4. Yeah, it's a two-tailed. From two-tailed is left tail, right tail. And we make the decision, the reject the null or not reject the null, right? And finally, step 6, interpretation. Yeah, it's a ignore this part. Yeah, it's a finally step 6, the interpretation of the decision. So now here, summarized 6 steps. We finished. Any question? What do you expect next? not. Do you remember the two parts? The two parts in chapter 8? Let me repeat chapter 8. Yeah, chapter 8 here. The big two parts, sigma is known. Yeah, absolutely, I have to add is unknown. It's practically the population standard deviation was unknown, but sometimes we assume we knew the sigma. The other one, sigma is unknown. I mean in chapter 8, confidence interval. The confidence interval was x bar plus n minus the z time sigma over square root of n. Let me add chapter 9 here. Testing. The hypothesis test. Step 3. The test statistic was the z-score. X bar minus mu 0 sigma over square root of n. Look at this. X bar z yeah, it's very similar. Yeah, we just rearrange, right? The letters to get the test statistic in chapter 9. Do you remember what was this? What was another confidence interval when we assume sigma is unknown? X bar plus n minus t score times s over square root of n. Do you remember? Absolutely, we didn't know what is the sigma. What was the population standard deviation? So we estimated it using the S. What is the S? Sample standard deviation. Because of that, we got the t-score from the t-table. And it was another confidence interval for unknown population mean. Okay, now, reorganized again. In chapter 9, who will be first? Who will be at the beginning? At the beginning, it was here, right? Who was there? Yes. We are going to take the t-score as a test statistic in step 3. Is equal to, in the right-hand side, it must be the fraction. Okay. In the numerator, who was first? X bar. Yes. X bar. Who was the next? You know, the mu 0 is actually the mu 0 was step number 1, the null hypothesis, right? So still, yeah, we have a mu 0 here. The denominator, who was the denominator? The second part, right? Same thing. Same thing. Exactly same thing. What's the difference? Now we don't have sigma. But we have a substitution. We substitute with the S. But we need a t-table. We are going to have a t-score. That is the only the difference. That is the only the difference. Please look at this. Next step. Next section. Hypothesis test for unknown. Please add unknown again. Then what? When sigma is unknown. Bless you. So now we can name on this. One mean t-test. Do you understand why it has the name t-test? Because we are going to use the t-score instead of the z-score for the test statistic in step 3. But please look at the step number 1. Exactly same. Exactly same. Step number 2. Same. Now, step 3. It is a new one, but it's quite similar. It's quite similar. Yeah, we are going to use the TP, right? Before, we got the p-value, right? I'm so sorry. It's no more p-value, but we are going to apply the critical value. It's a critical value. So now, step 4 and 5, decision, a little bit different, a little bit, because of the step 3. It's because of the t-distribution. We are going to apply a little bit different, the critical value approach, but finally, in chapter 6, yeah, we are going to make the conclusion, interpretation. It's the same thing. What's the new? Step 3, 4, and 5. That is a new one. But step 3, the step 3 is almost the same. Step 3 is almost the same, and only the step 4 and 5, that is a new one. The critical value approach. So it is the second approach. Before we used the p-value approach. Yeah, we got the p-value from the left tail, right tail, two tail. But now we are going to take the critical value, not the probability, but it will be the value from the TT. Okay, you got it? I think, yeah, property, yeah, level, yeah, and the price, yeah, we finished the 2 examples, apply the z-test, and now we have 2 more examples to apply the t-test. Yeah, please look at this. I think I can finish chapter 9 today. Yeah, it's tomorrow. Yeah, we are going to discuss chapter 10 Tuesday. Wednesday, review everything. And we are going to take the final exam Thursday. It sounds good, right? Yeah. The reason why tomorrow I can finish chapter 10, do you know why? We are going to repeat again. I took 2 days, last Thursday and today. Yeah, I finished chapter 9, right? But tomorrow, in a day, I can finish up chapter 10 because we are going to repeat again. Yeah, don't worry about that. Yeah, please look at this. It's the same thing, right? Yeah, step number 1 is mu is equal to something, an alternative hypothesis, right? And step 2, alpha, but now we need a t-score. Please read the examples carefully. Yeah, it is a reading problem. It's not a statistics, right? Yeah, please read. Oh, I can see the significance level. The significance level must be 5%. It's good, right? And what is the claim? The claim is, do the data is provide sufficient evidence to conclude that, on average, the high mountain lakes are non-acidic. Non-acidic. Anybody who major in biology? Uh-oh. No biology. pH level? The pH level is a level of the acidic or is non-acidic, right? Yeah, it's orange juice. Yes, it's orange juice or any that is the is an acidic, right? And water is a neutral, it's nothing, right? Yeah, and I don't know. Okay, we want to test. And the claim is the high mountain lakes are non-acidic. Non-acidic. It must be high pH or lower pH. How do you think? Oh, I'm so sorry. I'm not majoring in biology. I don't know.
I think acidic is low pH.
Just a second. Did you read the example?
That's on average.
It said, no. Please read the example carefully.
Are non-acidic, so it's high.
The lake can be classified as non-acidic when greater than 6. Non-acidic, greater than 6. Greater than 6. This makes sense, right? So we want to test if they are non-acidic. What does that mean? pH greater than 6. And what will be the null hypothesis? Equal to 6. Be smart. Be smart. Okay? It's a non-acidic means it defined. Yeah, because statistics is not only for the students in biology, in chemistry, right? Yeah. So kindly, it defined when is the non-acidic is greater than 6, right? And the test statistic. Can you remember the formula? So now we need the mean difference again, but we don't know what is this the sigma. We don't need the assumptions for the sigma, but we have a S here. Yeah. So let me give a tip. Any example give you the S, you have to take the t-score. Any example with the sigma, you have to use the Z. For the confidence interval or the testing hypothesis, it doesn't matter. Sigma will be Z. S will be T. Okay? Yeah, it's very simple. So what is the sample? What is the average from the 15 lakes? 6.6 pH on average minus the setting value 6 and S was 0.672 and how many samples? 15 lakes. Again, I suggest you take the numerator and the denominator separately. So the mean difference will be 0.6 and the denominator is 0.672 divided by square root of 15. I have a 0.1735. So 0.6 over 0.1735. It will be 3.46. But it will be the t-score, right? Yeah. So far, it's almost the same. But now we need the critical value. We have to take the critical value from the t-distribution. The t-distribution looks like the z, the standard normal distribution, with a mean equal to 0, right? Yeah. Before we plug the test statistic 3.46, and now it's greater than, so it was the right tail. So we got the right tail probability from the z table for the p-value. Do you remember that, right? Ignore it. That is the p-value approach from in the z-test, right? Ignore it. Now we plug the alpha. Alpha was the probability, right? So we plug the alpha, the probability, into the right tail. What did I say? We plug the alpha into the right tail. Why into the right tail? Because we stated right tail is greater than. It's almost the same idea, but we plug the probability, the alpha, into the right tail. How much was the alpha? Alpha is a 0.05. And now, what do we need? Critical value. See, before, I said many of you confuse the z-score and probability and the z-score, right? See, now we need the t-score. The t-score will be the critical value. Where will be the t-score then? The t-score must be here. The t-score. And it will be the critical value. So please make sure it is not a probability. Alpha was the probability, right? But the critical value is not a probability, but it must be a t-score. From where? T-table. So please look at the T-table. I don't have it. I'm so sorry. Just a second. I brought the thumb drive. Okay, it's good. Let me open the T-table. Yes, I have a T-table here. Yes, I have a T-table. Yes. Okay, good. T-table. Oh, T-table gave us right tail. Okay, how much probability we plug into the right tail? Alpha, 5%. So where should I go? 5%. We have to take a t-score from the second column. Because the second column, right tail, 5%. Good, right? Okay, good. Just a second. What's the df? The degree of freedom. Do you remember how many degree of freedom? How did you get the degree of freedom? N minus 1. How many n was in the example? 15 minus 1, 14. 14. 1.761. So now I can say the critical value, the t-score will be 1. What did I say? 1.761. Yes. So that will be the critical value. It makes sense, right? So far so good. Oh, now we have to make the decision. Step 5, we have to make the decision. Okay, now then, we can split two partitions. Already we got the critical value. Already we got the t-score from the t-table. It's named the critical value, 1.761. With the critical value, we can make the two partitions, left-hand side and the right-hand side. One of them must be reject the null hypothesis, and the other one must be not to reject the null hypothesis. Where do you think? Where do you think will be reject? No, don't look at that. You're cheating. Guess. Greater than, right? Right-hand side must be reject the null hypothesis. Why? Yes. Because alternative hypothesis is greater than. Right here. Yes. There is the decision reject the null hypothesis. Yes. So let me write here is a reject the null hypothesis. Definitely left-hand side not to reject the null hypothesis. It makes sense, right? So we set up is everything. How much was the test statistic in step 3? In step 3, we got another t-score, right? Another t-score, the test statistic from step 3. How much was it? In step 3, test statistic, t-score, so another t-score was 3.46. Here, the test statistic, step 3, t-score was 3.46. Where it is? In the right-hand side. What will be the decision then? Reject the null hypothesis. We found a critical value from the t-table to make the partitions, left-hand side and the right-hand side. But it was right-tailed. So if we have the test statistic is another t-score test statistic in the right tail, then we are going to make the decision reject the null hypothesis. The other way, if the test statistic in the rejection reason, non-rejection reason, then we are not going to reject the null hypothesis. But the test statistic was 3.46 in step 3. Reject. What will be true? What statement will be true then? Remember, who is your girlfriend? Who is your boyfriend? Alternative hypothesis, yes. The alternative hypothesis is must be true because we rejected the null hypothesis. How can you interpret greater than 6? Accident? Non-accident? Which one? Greater than 6. You forgot. Non-accident, right? So what will be the decision? Let me state the decision is up here. Decision. The high mountain lakes are what? Non-accident. Because we have to state from alternative hypothesis. It said greater than 6. What does it mean? Non-accident. Why? Because we rejected the null hypothesis. Why? Because the test statistic was in the right-hand side, greater than the critical value. Right here. It's good, right? Any question? So again, it is only the new one, the critical value approach. Any question? Last example. Yeah, perfect. We have 4 minutes, 5 minutes. Absolutely, we can finish up here. Step number 1, the null is equal to, it's HA. Step number 2, alpha, 3 t-score. Please read the example carefully. And why don't you give me the population mean? Unknown population mean setting in the null hypothesis, please. Remember, always we have 2 kinds of the means. One of them must be the population mean, and the other one must be the sample mean. And also, please remember, sample mean must be from the sample. So now, what is the value in step number 1? 4.55, yes. It is the old average in 2005. So let me plug the 4.55. Next, what will be inequalities? Yeah, it is a defer, yes. So what? Not equal to. Two-tailed. Remember, it must be two-tailed. Okay, can you see the alpha? 10%. Okay, then now I have to plug the 4.76 for the sample mean, and the initial setting unknown population mean was 4.55. And can you see the sample standard deviation? Here is the standard deviation. It's absolutely it was from the sample, right? With the sample mean 4.76. So the standard deviation 2.30 it must be S. The sample standard deviation. And how many sample? 20 people. Thank you. So let me see. The mean difference is must be 0.21, and the denominator is will be 2.3 divided by square root of 20. Then I have a 0.5143. Then the fraction will be 0.5143. 41. It's good, right? Okay, yep, it's almost the same. So far, it's almost the same. Okay, now let me apply the critical value approach. So let me make is another bell shape for the t distribution is a mean equals 0. Just a second. What did I do? What did I do? We plugged the alpha significance level of probability into the tails, right? Before we had right tail is greater than 6. So we plugged all alpha into the right tail. But now we have a two-tailed. Any idea? Both sides. How much and how much? Half and half. We split alpha half and half into the two-tailed. Does it make sense, right? We don't have any example for the left tail. For the left tail, less than, we plug the all alpha into the left tail. But now we have the two tail, it's not equal to. So we just split, it's a 50-50. Good. Give me the t-score, give me the critical value here. How much should be the right tail? The right tail, 5%. Oh, we have to go to the second column again, right? Even though alpha was 10%, but we split is half and half. So the right tail is only 5%. So we have to go to the second column. And now, how many degree of freedom? 19, 20 minus 1. So at 19, 1.729. Positive 1.729. Do you know how much will be the left one? But negative. Yes, same, but negative 1.729. Where we have, okay, now then we can make the 3 partitions. Because we stated not equal to two-tailed, so we have 3 partitions. But we had only 2 decisions, right? Reject the null hypothesis or not to reject the null hypothesis. Where do you expect to reject the null hypothesis? Just a second. Please remind where we rejected the null before. We stated the right tail. So in the right tail, we rejected the null hypothesis. Do you remember that, right? Okay, now we have a two-tail. Where must it be to reject the null hypothesis? Huh?
You said reject.
Please apply the same idea into the both tails. What is this? Two tails. right? So it's not only the left tail reject the null, but also the right tail reject the null. Don't change your rule, okay? Don't change, don't change. Then where is the not reject the null hypothesis? That is in the middle, yes. Does it make sense? Right? Yeah. Everything is in the right tail, is everything in the left tail, everything is will be the two tails. It's not only the p-value, but also the critical value to make the decision into the two tail. Good, right? So we set up the decision rules. Okay, now how much was the test statistic? The test statistic was 0.41. Where it is? 0.41. The test statistic was 0.41 in the middle. And now, what will be the decision? Do not reject the null hypothesis. Does it make sense, right? Okay, now, we do not reject the null. Then which statement should we interpret? I do not reject the null. Is the null. Yes, we have to state the null. We have to interpret. We have to interpret the null statement. Yeah, I understand. Yeah, it's very confused, right? Yeah. We remember, we did not reject. Reject means it's a negative, yeah, it's a situation, right? It's not negative, positive, right? Yeah, yeah. So we have to interpret the null statement. What it said is equal to 455. What does it mean? It's equal to 455. They changed or not? No. Yes. Step 6, no. No difference from 2005. Or even you can state it's not change. Whatever. Or even simply you just say same. Same as from 2005. Yeah, it's anyone will be good. It's a no change. Okay, that's good, right? Yeah. So in chapter 8, we have two kinds of interval estimations, confidence intervals, with the Z sigma and TS. Same thing. Chapter 9, the hypothesis test, we have two procedures. Sigma Z p-value. ST critical value. Good, right? Yeah. It's a time's up, so I do not give you the second quiz, but let me post the homeworks. So please do more practice. Do more practice.